Okay, let's put angles on graphs. So we're going to start off with theta r and theta STP. And as you can see in the notes, you have the full English instructions. Theta r, the reference angle, is the angle between the terminal arm and the x-axis. Between the terminal arm and the x-axis. So we'll talk about more about that. The angle in standard position, the theta STP, is the angle from the principal axis, the positive terminal arm, to wherever it is. Now, theta STP is everything. And theta r is a tiny little reference angle that kind of helps us do math. Trig. Okay, so let's draw a, black graph. And I'm going to draw an arrow going up to the right. And we call that, as you can see in the notes, the terminal arm. This theta right here is reference because it's between the positive x-axis and the terminal arm between 0 and 90 degrees. Now it turns out that by the definition of theta STP, it's also equal to theta STP, as we're going to see in the next diagram. So theta STP is the arrow. Theta r is the tiny little angle inside the triangle, which happens to be the same as STP in the first diagram. So I forgot to mark in my diagram 0 degrees and off to the left 180 degrees. Very useful to do that. We should do that every time. So let's do a graph off to the right. Whoops, whatever. And let's put in an angle of 45 degrees. You can put the rounded thing there if you want, but definitely the arrow tip. So 45 degrees. Well, theta r, by definition, is the angle between the positive x-axis and the terminal arm, wherever it is, between 0 and 90 degrees. It's 45. And the definition of the arrow going from the positive x-axis all the way around to wherever the terminal arm is, well, that's also 45. So that's also theta STP. So in the top quadrant, we'll talk about the names of the quadrants soon, but in the top right quadrant, theta r is equal to STP. Some funny circles showed up off to the left. Weird. All good. I erased those. Should be good now. Okay, so let's take a look at another diagram. So, you know what? These should be crosses. I'm sorry. I'll do a better job. Crosses. So, mark 0 and 180 like we should have done in the top right, but didn't. Whatever. And now, let's put the terminal arm going up this way. We know that theta r is the angle in between the x-axis and the terminal arm, wherever it is. Let's call that 50 degrees, whatever. And let's put an arrow from the positive x-axis to wherever the terminal arm is and figure out what that arrow is. So I've done the math, but we know that angles on a line add to 180. And 180 minus 50 is 130 degrees. Equals theta STP. Two types of angles. So you can see farther into the notes where we have an angle that's all the way around past 180. Let's look at that one. So mark 0 and 180. Then we have a terminal arm down in the left bottom quadrant. And let's say this time, let's give STP. So an arrow from the positive x-axis all the way around to wherever the terminal arm is. That's theta STP. Let's give theta STP this time. And let's say it's 220 degrees. We know it's past 180, and we need to figure out what theta r is. Well, theta r is the tiny little angle inside the triangle. I need to zoom in. This happens occasionally. Theta r equals, well, we know that it's 180 degrees all the way around, so we can simply just do 220 minus 180 equals 40. And we know that our reference angle is 40 degrees. So it's really going to be logic. You might be using 180 plus or minus, or 360 plus or minus like in the next example. They might give you the reference angle, the tiny little angle touching the x-axis, or STP, from the positive x-axis all the way around to wherever the terminal arm is. Might stop in the first quadrant, and they're both the same, like in the top right-hand corner, or not the same, and each other for reasons. They always add up to 180 either way. Excuse me, that's not always true. But angles on a line add up to 180, and then you can use that principle to figure out what the other angles are. So down at the bottom, we have our different quadrants. Whoops. One more time. Sorry. Okay, so in the first quadrant, 1, Roman numeral 1. Then going top left, 2, Roman numeral 2. Bottom left, 3, way out of the way of the graph, Roman numeral 3. And 4, Roman numeral IV. V is 5 and IV is 1 before 5, quadrant 4. And you can have a terminal arm in the first quadrant, or the second quadrant, or the third quadrant, or the fourth quadrant. And every time, theta r is right here. Lots of the times it makes help drawing triangles. We always draw triangles vertically. And we know that it's always a bow tie, not an hourglass or a spaceship or any other shape than this. And theta r is always the tiny little angle inside the triangle. We always get right angles. That's in red. I'm going to do that again in black. We always get right angles where we draw the vertical lines. We get right angle triangles. That's what we're doing. Right angle trigonometry for now. So in both the diagrams below, you have all sorts of different ways to figure out what theta r is or theta STP is, depending on what you are given and which quadrant it's in. But basic logic will calculate these much more easily in these ridiculous formulas. It's always going to be 180 plus or 180 minus or 360 plus or 360 minus or some combination of those things. Okay, so as you can see in the title, it's a little bit different than the title on the left there, because we're actually going to take a look at the next page of notes, and I'm going to put it on the same page. So let's take a look at the next page of notes. Either flip your page over in your notes if you've printed off the notes, or whichever. Either way, I have to shrink this up a bunch. Okay, so now let's talk about clockwise and counterclockwise. So remember, this is a clock, and the hands go this way around. So that's clockwise. So regular, as we've been talking about, let's say the terminal arm's here. Well, this theta STP is going against clockwise, so it's counterclockwise, CCW. Theta STP is CCW, counterclockwise. And for example, you could figure out what that angle is. If the reference angle was 50, 180 minus 50 is 130. 130 degrees. Now, I actually did that calculation down below, so I'm just going to move that down below the notes. You can leave it, but I just wanted it to, whatever, look better. So we can put 130 on that arrow. We can circle it because it's found information. So that's going to be positive going in the counterclockwise direction. But what if, in the notes, we go this way, and the terminal arm's down here, and the reference angle is 30, for example? I'm going to put an arrow tip on my arrow. Well, there's a very complicated version of the algebra or whichever math you want to do in the notes, but you'd rather just think, okay, it's 180, 0 and 180. I should be marking 0 and 180 on every graph. I did a couple above. So 0 and 180. So back this way, all the way is 180. I can't tell you how much monkey arm movements are going to help you remember this stuff better. So back to halfway is 180. Well, if we're 30 short, it's just 150. 180 minus 150 equals 30. But we know it's in the negative direction because it's clockwise. So theta STP equals negative 150. 180 minus 30 is 150. It's going in the negative direction, so it's negative. And it's negative if it's clockwise, the way that the clock moves that we just talked about a second ago. Okay, so that's theta r. And from the title, theta r and theta STP, positive is negatives. And let's now look at coterminal angles. So let's take an angle of 40 degrees. Mark 0, mark 180, whatever. That's STP. Now what if we take the same graph and we put the same little 40 on there, but instead of just going to the 40 arrow in the left diagram, we go all the way around past it and get to it again. Well, we know that we were already at 40. Then we do a whole circle, which is 360 degrees, so we can simply say theta STP is 360 plus 40. Keep in mind, you can do some crazy, difficult addition or subtraction or writing down formulas, but logic is going to be your best friend. We're 40 past 360, so 40 past 360 is 360 plus 40. Theta STP is in the positive direction. Theta STP equals 400 degrees. Now, that STP is also called something different. Theta coterminal equals 400 degrees. Now, these are both the same definition at the moment. You can have a theta STP in the first diagram, theta STP equals 40. Or another way around, all the way around, that's also STP, that's 400. And STP, there's also plus 360, 700 plus 360, 400 plus 360, 760, and then whatever plus 360, plus 360, etc. Called coterminal angles. Now, the next definition at the top is theta PRI. Now, down below at the bottom, theta PRI, the principal angle, is equal to the smallest STP angle between 0 and 360, and that's this one, not 400 or 760 or whatever we mentioned. 40 degrees. So we've seen above theta r, theta STP, in positives and negatives directions, and talked about coterminal angles and principal angles. So down below is a whole bunch of interesting math to figure stuff out. Let's say theta STP was 1,000. Well, how many times around is 1,000? Well, we can do a whole bunch of ways. We can just keep subtracting 360 until we get a number like we did on the left, 280. Or we can divide it by 360, get 2.7 repeater. No, that's 2 full circles around, so 2 times 360. And then the repeater times 360 as well. And then get the answer. There's just so many ways to do it. Logic is your best friend. So, those angles at the bottom, theta principal, underlined in blue, not as common. Coterminal, not as common in grade 11, but very common in grade 12. Theta STP is the one we want at the top all the time. And theta r is a tiny little grade 10 angle that allows us to more easily do grade 11 trigonometry. So, those are those 4 types of angles. Remember, it's all about STP. Okay, great. Let's get into graphing more triangles.